Checking 1, 2, 3. Okay, it's good. Right. So we continue from last time. I hope you have something like what I have here. So we have like quick reference. I have one for the hexagon trick, one for the definition using x, y, and r, and one is the quick reference for the special values. Right, those are the three things I have for now. When we stopped last time on Tuesday, this is what we have: the definition of trigonometric function using the right triangle. And for the right triangle, the definition is only for an acute angle. So if it is less than 90 degrees, we can use the right triangle. And this is the definition. Right. So I have one for that too. Now, see if we have a right triangle. Right. And the angle is going to be here. This is the opposite side of that angle. And this is adjacent. And the longest side is the hypotenuse. Right. And then with that we define the trig function. Let angle be angle A. Sine is opposite over hypotenuse. Cosine adjacent over hypotenuse, and then tangent. Opposite over adjacent. Right. And then cosecant, secant and tangent are reciprocal. And secant hypotenuse over adjacent, and cotangent adjacent over opposite. Right. And because we have two mnemonic to go with it. Right. Now to be consistent with what we have before, now if we have we draw the coordinate system. At the y-axis and the x-axis. Here there's the point x and y, meaning the vertical distance is y, horizontal is x, and hypotenuse is r. When we do that, we have the same ratio, y over r for sine, x over r for cosine, and y over x for tangent. And then we just flip all of this. So the definition using x, y, and r consistent with the definition using opposite, hypotenuse, and adjacent, opposite, hypotenuse, and adjacent. But when we define using the right triangle, this is only for the angle between 0 and 90 degrees, an acute angle. Right. So we continue from last time. Uh, 2.1 actually. Right. Example. Now we'll find sine, cosine, and tangent. For angles A and B. Right. Now we have the first example. All we have is a picture. So the angle here is A, 5 and 13. The right angle is C, so this is angle B. Right. Right. So it is easy. So before we do anything, the hypotenuse is 13. This is 5. We're just going to find this side. By the way, by the convention that we define for the triangle, opposite to the angle C is the sine C. Opposite to angle A is the sine A. So this will be sine B, opposite to angle B. And in this right triangle, 13 is the biggest one. So we'll have A squared plus B squared equal to C squared. A 5 squared. B don't know. C squared 13 squared. Right. So for B, 13 squared is 169. Do that later. And then 5 squared 25. So that should be 144. So B squared 144. So for B, it is plus or minus square root of 144, which is plus or minus 12. Right. So that. However, this is a triangle, so we only take the positive values, because a sine of a triangle cannot be negative. So I just say measurement cannot be negative. Right, so let's positive 12. Right. Now, the question asks for sine, cosine, and tangent. So sine A, cosine A, and tangent of A. And then for B, sine sine B, cosine B, and tangent B. Right. That should be very straightforward. Now, we do for B, for A first. With respect to angle A, with respect to this angle, this is going to be opposite to angle A, and this is going to be adjacent to angle A. Hypotenuse is always tucked in. It's always the longest side. So that. Now, and then we just base on the definition. Sine is opposite over hypotenuse. Opposite is 5, hypotenuse 13. Cosine adjacent over hypotenuse. Adjacent 12. Hypotenuse 13. And tangent opposite adjacent. Opposite is 5, adjacent is 12. So it's straightforward. Definition. Yes. Right. Next, we do sine, cosine, and tangent for angle B. Now, with respect to angle B, this side is opposite to it. So with respect to angle B, opposite is this side, and then adjacent to angle B is this side. Hypotenuse is still C. Right. So it depends on what angle we're talking about. We have opposite to that angle and then adjacent to that angle. So for sine is opposite over hypotenuse. Opposite with respect to angle B is 12, and hypotenuse is 13. Cosine B, adjacent over hypotenuse. Adjacent with respect to angle B is 5 over 13, and tangent opposite over hypotenuse. Opposite with respect to angle B is 12. Adjacent with respect to angle B is 5. So pretty straightforward. Just if we have the graph, just make sure that the adjacent and opposite with respect to an angle. Two. Now we have another triangle. So if this is A, then this is going to be B. Right? And opposite to angle B is 6. So this is B. Opposite to angle A, sine A. And opposite to angle C is sine C. Right. A squared plus B squared equal to C squared. And we're going to solve for C. Right, A squared 64 and 36. So we have C squared equal to 100. So we have C equal to plus or minus square root of 100, which is 10. And once again, we just choose the positive. The nice thing about trigonometric using a right triangle is that all of them will be positive. Yeah. So in the first quadrant, from 0 to 90 degrees, everything is positive. All the trig functions are positive. So don't have to worry about the negative case. Right. Now we have sine, cosine, and tangent of A. Sine B, cosine B, and tangent of B. Right. Now, sine of A, opposite over hypotenuse. With respect to angle A, opposite is 8. Hypotenuse, we know, is 10. Both of them are even, so reduce to 4 over 5. Right. Next, cosine. Adjacent over hypotenuse. With respect to angle A, that is opposite. This is adjacent to the angle. So it will be 6 over hypotenuse is 10. 3/5. Tangent, opposite over adjacent. Opposite is 8. Adjacent 6. Reduced to 4/3. Now with respect to angle B, opposite to angle B and hypotenuse. Opposite to angle B is the sine B, which is 6 over hypotenuse, always that one. Next, adjacent over hypotenuse. Adjacent to angle B, this is angle B, adjacent to it is that. Hypotenuse is still 10. And opposite over adjacent. Opposite with respect to angle B is 6. Adjacent to angle B is 8. Hypotenuse is 10. So it should be easy. We just have the definition using the right triangle trigonometry. Just that. Now what we go to the next part is what we see here. What we see here is on the first one. Notice that with respect to angle A and with respect to angle B, adjacent of this with respect to this angle is opposite with respect to the other angle. Because of that, what we see is, you see the sine of A will be the same as cosine of B. Right? Because with respect to angle A, opposite is this side. But with respect to angle B, adjacent is that side. So it depends on what the angle we're talking about. The opposite or adjacent is going to be adjacent and opposite of the other angles. We don't do the we disregard the 90 degrees because this is trigonometry of the right triangle only. I mean of acute angle only, meaning it have to be less than 90 degrees. once again, opposite with this angle with respect to this angle is adjacent with the other angle. Likewise, cosine of this one is equal to sine of the other one. Right, so those two are equal. And those two are equal. Yeah, because we're switching the role of yeah, this one I just wrote wrong. That still is yeah, thank you. This is adjacent. Yeah, the number is correct, but I went to cruise control for a moment. Sorry. That's what you're talking about, right? Yeah. And the number is correct, but I just write it wrong. Right. Next, cofunctions. Right. So this is just by the name of it. Let me zoom in. So when we say sine and cosine are cofunction of each other. Tangent and cotangent. Are cofunction of each other. And then secant and cosecant. A cofunction. So it is not that difficult when we actually spell it out. There is the cofunction of each other, and it's not cosine is a cofunction of sine. They both are cofunction of each other. With the green one. Of each other. Right. Boom. Cofunction identities. I'm not going to even write all of them out because that's unnecessary. So the thing here is when we have sine of A is equal to cosine of 90 degrees minus A. And this works for all the trig function. We go for the function to the cofunction. Tangent, cotangent, and secant, cosecant. Actually, just write everything out. Then cosine, go back to the cofunction of cosine, which is sine. Tangent, cotangent of A, tangent of 90 degrees minus A, and cosecant is secant right. So we will say a trig function of an angle is a cofunction of the, by the way, A and 90 minus A, meaning that those two angles add up to 90 degrees. So we call that add up to 90 degrees of complementary angle. Right. So that's how the theorem says. Right. We have just little note here. Complementary angle, the way we defined it earlier, it is only for acute angle, but when complementary angle here, we extend that to as long as sum equal to 90. So for example, if we say A is equal to negative 20 degrees and angle B is 110 degrees, they add up to 90 degrees. So that still work. Doesn't have to be an acute angle. Doesn't have to be between 0 and 90 degrees. This theorem will work for sure. Right, let's see how it works. See example. Express express the following using cofunction identity. Now this should be very easy. Sine of 13 degree, tangent of 67 degree, and cosecant of 115 degrees. Right. Right. I said, this is not complementary angle. We extend that to the sum of 90 degrees. So what you said, instead of complementary, let's just say that the angle is whose sum equal to 90 degrees. Because we did define earlier, complementary only works for 0 to 90 degrees, right? So the negative here actually doesn't work. But, like I said, as long as the sum is equal to 90 degrees, this theorem works. So it doesn't have to be complementary. It will work if they add up to 90 degrees. That's what I mean. So instead of saying equal to complementary angle, we just say that as long as the angle add up to 90 degrees. Right. We'll see. Right. So first, using cofunction identity. So we cofunction of sine is cosine. And when we do that, we go from an angle to 90 degree minus the angle. And that is 70 7 degrees. And because 13 and 77 are complement of each other, which is perfectly fine. But the key here is, if you want to go from a function to a cofunction, just subtract the angle from 90. That's what I mean. So from tangent to the cofunction, we have to take 90, subtract that original angle. And that is 23. Right. And same thing for cosecant. If we want to go from a function to a cofunction, we subtract the angles from 90 degrees. And that is negative 22, 25 I mean. So it doesn't have to be an acute angle. It doesn't have to be complementary angles. When we go to a function to a cofunction, just subtract from 90 degrees. And that identity will work. Example, solve for theta. Right. Now what we have here is we want from a cosine to sine. So those two are cofunction of each other. It will work if the angle here and the angle here add up to 90 degrees. By the way, I'm sorry. Let's change this to a plus. This will be a lot more interesting. Right. Change the problem to a plus. Right. From a function to cofunction, as long as the angle add up to 90 degrees, that's good. So this will work if 15 degrees plus theta plus 15 degrees equal to 90 degrees. Coterminal angles, yes. If you have coterminal angle, that's still fine because coterminal does not change anything. For example, if we go from cosecant of 115 degrees, you can go to secant of what we have is negative 25 degrees, and then we can also say we can always add 360 to it, and the values will not change. The values of the trig function will not change. Yeah, so cosecant here also equal to secant here. Yeah, so they don't have to add up to 90 degrees for it to work. But if they add up to 90 degrees, it will work. Right? So it is one side or another. Let me say this again. They do not have to add up to 90 degrees to work. But if they add up to 90 degrees, that's guaranteed to work. Just one implies the other, but the others do not imply it back. Right. In that case, we should say solve for theta. just one values of theta. There will be a lot more angles, a lot more values given by coterminal angles, but this is just one values for theta. Right, this is easy to solve here as long as the angle add up to 90 degrees. We can always say or coterminal angles. That's still fine. But since you only need to find one values of it, we do not have to have the 360 degrees. I hope that answers your question. Yeah. So instead of adding to 90 degrees, they can add up to 450 degrees. That still work. Anyway, so 15 plus 15, so that's 30 degrees plus theta equal to 90 degrees. So theta is 90 minus 30. So theta is equal to 60. So 15 and 75 are complement to each other. That certainly works. 2. Well, we go from tangent theta to cotangent of theta plus 20 degrees. Right. We go from a function to cofunction. It certainly works if they add up to 90 degrees. And we have 2 theta plus 220 degrees. I subtract 20 on both sides. 2 theta equal to 70 degrees. So theta 70 degrees divided by 2 is 35 degrees. Yeah. Right. Right. Trigonometric function values. And application. Example. Right. I don't know. I have to read that. I just read right in front of me. Right. We have a triangle ABC, which is the right triangle. Let me just write it. Suppose ABC is a right triangle. Yeah, usually we say a right triangle at C, we mean C is 90 degrees. If A is 5 and C is 13, 5, 6 trig values of A. Right. The nice thing about this solving the right triangle, we do not have to draw that up to scale. Just get the idea of where the angles and where the sides are. Right. We know that C is the right angle. We just say A is here and B is there. The angle A, opposite to angle A is the sine A, which is 5. And opposite to the angle C is the sine C. So if we draw all of the if we try to find all the trig values of A, we need to know B as well. So Pythagorean theorem, A squared plus B squared equal to C squared, where C is the right angle. So we solve for B squared. Uh, 13 squared is 169. 5 squared 25. That will give us 144. So B plus or minus square root of that. And we just take the positive values, because the side cannot be negative. With that, then we just define all 6 trig functions of A. So sine of A, opposite to A, just spell opposite over hypotenuse. Opposite, hypotenuse, cosine, adjacent, hypotenuse. Now we know it's going to be 12 over 13 tangent of A, opposite over adjacent, opposite over adjacent. Right. Now cosecant, just reciprocal of this, so just say 13 over 5. Secant, reciprocal of sine, reciprocal of cosine is 13 over 12. And cotangent is 12 over 5. So we just flip onto this and we have the other function. B. Now use calculator to find sine of 23.5 degrees. Right, it's just a calculator. By the way, if we use a calculator before we use any trig function, sine, cosine, and tangent, make sure it is in the right mode. It's very important. So hit mode, make sure it is in the degrees mode. So go to degrees and hit enter. It have to be there. Once again, it's under mode, and it have to be degrees. Right. Once we done second and mode, get back to the screen. Right. Sine of 23.5 degrees. Sine of 23.5. If it is degree, we don't need to enter anything. And that's. Right. So, just calculate those. And you say how many decimal number do we need? Usually 3 or 4. Actually, it doesn't matter. The question will tell you how many decimal digits do we need. And then cosine of 15 degrees, 24 minutes. Right. Cosine 15 degrees. If we want degrees and minute, we have to hit second, amps, and degrees, and then 24 minutes. Second, amps again. Go to the second one. Right. Right. Next, we have an application problem. So just using the calculator, but have to be in the right mode, the degree mode. Right. We have a boat attached to the by a rope at water level, tethered to a dock that is 5 feet above the water. So I try to draw the picture. So let's see, we have a dock here, and here's our water. Right. And tethered that we have a boat. Say a boat. And tether to the boat at the water level 5 feet above the water. So the rope is at the water level right there, and tethered to a dock, and the distance is 5 feet above the water. Find the length of the rope. Assume the angle between the rope and the dock is 60 degrees. So we have here angle 60 degrees. Right, so let's say it. Here's the boat. Here's the dock, and here's the water level. Right. So we'll just draw a big triangle. What is the question? Find the length of the rope. So this is x. Right. Usually we just draw the picture, and then we ask to find x. Now, to do this is pretty simple. With respect to angle 60 degrees, with respect to this angle here, the 5 feet is adjacent to it, right? and the x is going to be the hypotenuse. So sine, cosine, and tangent, which one has adjacent over hypotenuse? Right. So we have the problem that involves the adjacent and hypotenuse. So it's going to be this one, adjacent over hypotenuse, which is cosine. So we just draw the picture, put in the thing that we know and what we don't know. And this problem involves adjacent and hypotenuse, and the ratio for that should be cosine of A. So we say cosine of 60 degrees equal to adjacent, because that is cosine, over hypotenuse. Adjacent is 5, hypotenuse is x. Right, so cosine of 60 degree equal to 5 over x. Usually for this kind of problem, I would write that cosine of 60 degree over 1 and cross multiply. So we have x times cosine of 60 degree equal to 5, and then we just divide by cosine of 60 degree. Right, cosine of 60 degree cosine is the number of fingers on the right, so that is square root of 1 over 2, or 1/2. Five divided by 1/2 is like multiplied by reciprocal, 5 times 2. 5 times 2, which is 10. Right, of course, we can also use a calculator. 5 divided by cosine of 60 degree. The calculator is still in the degree mode, so that works out 10, right? Right. Before we go to the next section, one thing I have to mention is that we did this on the second day, where we have the special trig angle. This is in section 1.2. It says, opposite to angle 30, 60, and 90 degrees are sides with the length 1/2, square 3 over 2, and 1. So go to this example. If that is 60 degrees, this will be 30 degrees. And opposite to 30 degrees is 1/2, and opposite to 90 is 1. So this side is going to be twice as long as that side. The side that opposite to 90 degrees is twice as long the side that opposite to 30 degrees, which is consistent to what we have here in our problem. Yeah. So usually the trigonometric function values, we can use the triangle to find the values, either 45, 45, and 90 degrees triangle, or 30, 60, and 90 degrees, or we use this trick. Later on we can use the unit circle. A lot of options to find the trig values. The calculator is not going to be the best option because sometimes it does not provide you the exact values. Right. With that, we go to the next section. Solving right triangle. The first part that we have here is significant figures. I'm sure when you take in physics or chemistry, you we'll go over this again, but just here's the basic about the significant figures or significant digits. First, the rule. Number 1. The digits from 1 to 9 are significant. Two, the leading zero are not significant. Zeros between non-zero digits are significant. And the trailing zeros are usually not, except if there is a decimal point. Right, just write out a bunch of rules here. But what is the significance of significant digits? What is the importance of this? So I'll give you a sample here. Let's say you want to buy something. Let's say gold, for example. Try to buy gold. And one guy, they have the scale, they up to 0.0001 ounce. And the other guy, they only have the scale, but only work up to 1 ounce. So one guy used the scale that is a lot better than the other one. This one is a lot better than that one because it is more accurate. So in that case, of course, we're going to stick with this one because whatever we buy, it will be up to 3 decimal places. So a lot more accurate than this one does. So the significant digits are how many of them are accurate? By the way, those two are not. For example, if you got this one, you can get 0.50 and 1 with that scale. But on this scale, all we can say is 0.5. We don't know what happened after that. What happened after that is not significant. But on this guy, what we know is 3 digits. And of course, this one is a lot better than this. But then you say, of course, we can also see the case like this one too. So, of course, the more digits, the better. And the rounding are not significant. So, let's look at the first example. Decide which digits are significant. In physics or chemistry, they just call the significant figures or sig fig. So first number, the rule says the digits 1, 2, from 1 to 9 are significant. So this one significant, this one is significant, the 3 is significant. Right. The leading 0 are not. We don't have any leading 0. The 0 in between also significant. So this one also significant. The trailing 0 are significant if there is a decimal point. There's no decimal point here. So these two are not significant, because those are the trailing 0. Those 4 are significant. 2, 0.0, 1, 2, 0.50. Right. Now, just read the rule. 1 to 9 are significant. So 1, 2, and 5. And any 0 in between also good. So those are significant. Any numbers different than 0 from 1 to 9 will be significant. If we have 0 in between, also significant. Right. Next, leading 0 are not significant. So those are the leading 0 before those numbers. This will not be significant. The trailing 0 are significant if there is a decimal point. There is a decimal point here. So this 0 is also significant. There's no decimal point on the top. So that one is not significant. By the way, if we want those 0 to be significant, if we add the decimal point just like this, then the 0, 0 here will be significant. If it is not significant, that means it can be rounded. And so we're not sure about this. Right. Next, those two are non-zero. Obviously, is significant. And there is the decimal point. So that 0 is also significant. So depends on there is the decimal point or not. Even though there's nothing after that, this still considered to be significant. So if there's a decimal point, anything after only 0 after that is still significant. If we don't have the decimal point, not significant. The 0 before in front of the numbers will never be significant. The one in the middle is always. So the one in the middle is always significant. The one on the back depends if there's a decimal point or not. The one in front will never be significant. All right, I take 5-minute break. We continue at 2:09. Oh no, I mean that I only need to do this discussion once. Right. Now, I thought I did this on the first day already. Apparently, I did not write that down. So this is what we have on the first day, right? Yeah, on the 31st. I keep on the written note by the date very carefully. Right. And one part that is very important that I forgot to mention, and somebody just asked, is most of my class, this is for my math lab homework. And I guess the review counts as homework as well. Right. For each section, for each assignment, I will round to 100 if you make 90 or more, and I will keep it as is if it is less than 90. Right. Because some of the homework question I don't think the patient let you download the book. You can download a few pages, but not download the whole book. Yeah. So get this is an advantage of being in class. I mean, not being in class, but watching the video is that now you know you don't need to get 100% on all of them. Right. Once again, this is for each section. Like for chapter 1, if you make 90% or more, I will round to 100. If you make 89.9%, it will stay 89.9%. Like I said. If it's 990 and above, 89.9, it will stay 89.9. Right, so that is about the homework. We also did not mention the test yet, but there's the test review. After Tuesday, when we go a little bit more of this, I will explain what we will do with the test. Right, now we continue. So somebody also asked about the textbook on MATLAB on Pearson. You can view them and bring out a few pages, but they will not. You cannot, or you can download a few pages, I guess, but you cannot download the whole book. Oh, Paxi's note. So, the first one, when we multiply or divide, the result should go with the fewest significant digits. So go with fewest significant digit. And then when we add or subtract, and the rule says will be rounded to the last digit that is significant to both. So those are the rules. Let's see how it works. First, we have 1.2 times 325 hundredths. Right. So, of course, we just multiplied it. Let's say using the calculator. So that is 39,000, right? Now, let's say, so that is the math, but the sign to it, the significant figures, we have two. This one we have two significant, let's say two significant figures. And here we have 3. The trailing 0 doesn't count. So we have 2 and 3, and we're going to go with the fewest one. So the answer should only have 2. So which is correct? Now, the tricky part is I have to make some change here. Let's say instead of that, what we have is, just have to make different the sample. Let's say we have problem number 2. We have 1.20 times right. Of course, we know the math is 39,000. So, but what is the difference here? This guy, the zero, the trailing 0 will be significant if it has a decimal point. So, because of a decimal point here, all 3 of them are significant. So 3 significant digits or significant figures, and the trailing 0 doesn't count here because there's no decimal. If there's a decimal point here, that's a different story. So only 3 significant digits, and we'll go with the fewest significant digit. In this case, that will be 3. So all 3 of this will be significant. But then you say, what is the difference here? How can we write that? With this 0, that is significant. The only way to do that is we have to write as 3.90 times 10 to the, right, let's move decimal point. 1, 2, 3, and 4. 10 to the 4th power. In which case, it has 3 significant figures. And so sometimes we have to write that as the scientific notation if we want exactly the numbers of significant figures. Here there's 3 of them. We have to write like this. There's 2 of them. It's okay to write like this. Or we can say 3.9 times 10 to the 4. Yeah. So here exactly we know there are 2 significant figures, and here there are 3. Yeah. Sometimes we have to make that several change to scientific notation. Right. By the way, don't worry about this. Usually the significant figures, you worry more of that in chemistry and physics. This is the math class, so we assume that all the calculation is exact. So I'm not worried too much about this. Alright, so we have 3.205 and then add 12.5. Right, and then we just add like we normally do. That would be 15,705. Right, now the question said with the correct significant digits. So which of them are significant. So the 3, all of those are significant, and all of those 3 are significant, but we have to round it to the last digits that are significant to both. We have to round up to this point because those are the last digits that are significant to both. So we have to round to that point. So when we add them properly, it will be just 15.7. We round to where we have the last digit that's significant to both. The 0 and 5 here is significant. Yeah, we're not sure what happened after that. So just 15.7. Yeah, if we have 0, 0 here at the bottom, at the end, different story. But since we don't, we have to round to that point. Sorry, I changed. So this will be number 1 and 1A. Okay, let's do that. This is 2, 3. I spent quite some time here too for this section, but later on, like I said, I'm not worried too much about significant digits. The physics and chemistry will do that a lot more than I do. Right, now we divide. Let's use calculator. 123.5 divided by 47. So I have 2.6. 2765 26 574. Right, that's what I have on the calculator. However, the top number has 4 significant figures, 4 significant digits, and the bottom has 2. And when we divide or multiply, we only go with 2. So the answer to this is we have to round right at this point. So just 2.6. We can only have 2 significant digits here. So that is 2.6. The answer must be 2 digits. 2 significant digits. Just like the smallest number. I mean the number with the least significant figures. Right, 1000 minus 12. So 1000 minus 12. Right. So first we do is those zeros are not significant because those are the trailing zeros without the decimal point. So on this one, when we subtract, that is 990, 88, but none of these are significant because those 3 are not. So when we do this, it's just round to 1000. So the 12 actually doesn't do anything because we're not sure about the 3 zeros here are significant or not. Right, like I said, I'm not worried too much about those things. What I'm worried is can we do the math and solve the problem? Because in real life, even in real life, the approximation usually, if they have enough digits, should be good enough. And the calculation we assume here is exact calculation. Yeah. So when you write the answer like this, I assume that it has a lot more decimal places. And we can write as much as we can, but we just decide to stop here. So in the spirit, the answer, all of those answers will be exact. Next we go to solving right triangle. This is a lot more important than the significant figures. Right, to solve a triangle means find all the length and all the angles. Right, let's see what do we have. First example. Solving triangle ABC. Angle A is 32.7 degrees and sine C 14.3 inches, and C is the right angle. So it could be nice if we always have to draw the triangle to get the idea of what do we need and what we need to find. What do we have and what do we need to find. It doesn't have to be the right scale. Just a triangle like that. Angle C is the right angle. Angle A is 32.7 degrees. And the sine C (14.3 inches). Right, so those are what we are given. Of course, this will be angle B, and we do not know angle B. We do not know sine A. I mean, sine A will be here, where we don't know either. And the sine B opposite to B, we don't know either. Right. So that's all we have. Right. So how do we do this? Usually we know all the information. So let's say 32.7 degrees. We know the sine C, which is with respect to angle A, C is going to be hypotenuse. Actually, with respect to any angle, C is going to be hypotenuse, regardless, because that is the longest side. With respect to angle A, we have opposite. I mean, adjacent is here, and opposite is here. Sine A, adjacent, opposite. Now, just need to pick something that we know and something that we don't. So first thing we can do is, doesn't involve any trigonometry, just geometry. It's always the sum of all angles is 180 degrees. So in that case, we know A, 32.7. We know C, 90 degrees. We just don't know B. But can be subtracted from 1 can be subtracted from 180. Minus angle A, 32.7. And angle C, 90 degrees. Right. Calculator. 180 minus 90 minus 32.7. Right. 57.3. So that is B. Right, I say we're trying to find B and we're trying to find A. Let's try to find B first. To find B, with respect to angle A, we have adjacent and hypotenuse. So what ratio that has adjacent and hypotenuse? Adjacent and hypotenuse, that is cosine. So cosine of 32.7 adjacent over hypotenuse. Adjacent we don't know. Hypotenuse we do know. 14.3. Right. So we'll divide this over 1 and just cross multiply. So when we cross multiply, B times 1 is B, and 14.3 times cosine of 32.7 degrees. Right. For that angle, we have to use the calculator. Right. If we use a calculator with degrees, hit mode, make sure it is in degree mode. So 14.3 times cosine of 32.7. So we have 12. Just say 12.0 inches. The reason I use 1 decimal place because that one has 1 decimal place, so let's stick with that. Right. So we know B, which is 12.0, and we know angle B, 57.3. Just need to find A. There's a lot of options to find A. 1. Pythagorean theorem. We know 2 sides. We can find the third one easily. That's one way. The second way, the second method is we use this angle and use trigonometry to find it. And then 3. What we do is we do similarly the angle here with respect to angle 32.7 degrees, we have opposite over hypotenuse. So sine of 32.7 degrees equal to opposite over hypotenuse. Opposite we do know, actually we don't, that is 8, and hypotenuse 14.3. And cross multiply, A equal to 14.3 times sine of 32.7. 14.3 times sine of 32.7. And we have 7.7 as inches. The problem in my math lab, it will tell you how many decimal places that they want, so we know where we round to. By the way, this will be my preferred way to do it, because if we have to use the 57.3, those number we calculated. The 12 inches here, those numbers we calculated. That's why I write different colors. So we try to use the number that are given. It's much better than we use the number that we calculated, because when we calculated those two numbers, it may or may not have some rounding error. Certainly there is rounding error here when we round the 12, right? So always use, actually I'm not even worried about that, but ideally we prefer to use the number that are given and not the number that we calculated. The number are given is better than the number that we calculated. By the way, if we have to use the number we calculated, use a bunch of decimal places and then we round in at the end. Do not round at the middle of the problem, just round in at the end. Right. Now we have another example here. Yeah, I guess that deserves a note. We prefer to use given values over calculated. Because they will be more accurate. Right, example. Solving the triangle ABC. Yeah, so solving right triangle meaning we find all the missing length and angle. Solving right triangle. Sine A is 18.91, B is 21.48, and C is the right triangle, the right angle, sorry. Right, just write a triangle and then put all the information we are given and then trying to figure out what we missed, what we don't have. That is to solve a triangle. Right, C is the right angle, that's what we know. And say angle A here and then B here. A is 18.91, that's what we are given. Angle A we don't know, but opposite to angle A is the sine A, 18.91. Opposite to angle B is the sine B, 21.48. Like I said, the scale doesn't matter, even though that number is bigger than this number, but it doesn't matter. We do not know angle A. Let's do that in red. And we do not know angle B. Only know angle C. And we do not know the sine C either. Right, so we are given three things. The right angles, two sides, asking to find the missing information. Right, so it's not that bad. What we can see here is we have B, we have A, certainly we can find C. That is Pythagorean theorem, right? So first, not even trigonometry yet, just Pythagorean theorem. Just like the last problem, we use that. This time we use Pythagorean theorem. Because in order to do this, we need two angles to find the remaining one. This one we are knowing two sides. We can find the others. Right. We show for C. So C square equal to A square plus B square. 18.91 square plus 21.48 square. So 18.91 plus 21.48. Right. Now, in the middle of calculation, even though we only write a few digits, but if we use the calculation, we use the number that are given. I mean, if it's not given, we have to take all the decimal places and only round it back at the end. So we take the square root of that. So square root, and we can just go up, highlight the number, and hit enter. So that copy and paste 28.6178. And on this one, since they use two decimal places, so we just do that and keep two decimal places. So this we have to round to 2. And centimeters, so centimeters. Right, so we found that 28.62. Right, now we just need to find angle A and the angle here. Right, now we could use these numbers, we could use this number or this number, but if I have a choice, I will use this number because this is given and this is given. That one is calculated. I prefer not to touch that. Right, so we're trying to find angle A. With respect to angle A, what we have is opposite to angle A and adjacent to angle A. So we write out sine of A equal to opposite over, sorry, we cannot use sine, right? So what ratio that has opposite and adjacent? That could be tangent, right? Opposite over adjacent. So we have to use tangent. Opposite over adjacent, that is tangent. Opposite 18.91 over adjacent 21.48. Still need that. Right, so we will do that first. 18.91 91 divide 21.48. Even though I only write two decimal places, if I use the calculator, I'm actually going to use all of the decimal places here. See, I'm not sure, just write a few more. Yeah, that's fine. Now, we have tangent is equal to that. To get back to the angle, we haven't done this before, but if we know the ratio of a trig function, to get back to the angle, what we do is, we use the tangent inverse. So second and the tangent button. So we say it's tangent inverse it will take a ratio and return an angle. So we do tangent inverse, second tangent, and then just highlight the numbers, copy and paste, highlight the number, and then hit enter. Right, I got 41.3592. Let's just round to 41.35, let's say 36 degrees. Yeah, so A is the calculated number, 41.36 degree. And the remaining angle B, we can just subtract 180, subtracting that. Right. So angle B is 180 minus angle A minus angle C. $48.64. This is very easy to do. However, in terms of accurate, what we do is not easy to find, right? But we should use B equal to 21.48 and A equal to 18.91. We should use the number that are given, not the number that we calculated. So now, with respect to angle B, this side is going to be adjacent and that side is going to be opposite. So with respect to angle B, we have opposite and adjacent, so that's going to be tangent. Opposite is 21.48, adjacent 18.91. Yeah, so we have to set up with respect to some certain angles. Right. 21.48 divided by 18.91 is 1.1359. And to get back to angle B, we do the tangent inverse. So second tangent inverse, go up there, highlight, copy and paste. 48.64 degrees. Yeah. Of course, they usually are the same, but the big deal here is we use the number that are given will be better than the number that we calculated. By the way, like I said, I'm not worried about it. As long as we take a bunch of decimal places, should be fine. Only round up at the end. Do not round from the beginning. Right. Here we have some application here. Angle of elevation and angle of depression. So the definition is, of course, on that note, all we need is, I just going to draw a picture instead. So first, if we have a horizontal line, and we have an eye level, so let's say an eye level look horizontally. If we look up, this is called the angle of elevation. So we're looking up from the horizontal line. Now if we're looking down, actually there's no that direction here, so this angle of depression, and that is only between 0 and 90 degrees, even though, I mean, if the horizontal line like this, even though you look with that angle, that doesn't count. Angle elevation is to match with the horizontal line, so it will be on this side instead. So the horizontal could be forward or backward, as long as the angle is from 0 to 90 degrees. Right. It's better to draw the picture. It's better than 1,000 words. Right. So again, I'm just going to write, draw the picture instead of writing everything out. So a girl is flying a kite. How long of a string must be if the kite is 200 feet above the ground, and if the angle of elevation from her eyes to the kite is 25 degrees and her eyes are 5 feet above the ground. So first of all, let's see, I just draw a person here. That on the ground level. Right. And the kite from her eye level, and the kite will be somewhere up here. And try make a butterfly, for example. Okay. Or dragonfly, whatever. So that is a kite. A string, we assume that the string is perfectly straight and there's no, usually the string, it should be hanging a little bit like this, but in this case we assume that it's perfectly straight. And the kite is 200 feet from the ground. Her eye level though is only 5 feet off the ground. So because the eyes are 5 feet off the ground, the horizontal line will be 5 feet off the ground. And the angles of elevation, (25 degrees). Right, so that's what we have. The question is, how long of a string must be? I should put a question mark on the note, but the question is, they say the string here, what is the length of that? So first of all, the distance from the ground, that is 90 degrees. And since the total is 200, take away 5, we only have 195 here. So actually here is only 195. From the kite to the ground, to the eye level, 195 feet. And then we ask to find x. So quickly, 195, 25 degrees, and x. Now with respect to 25 degrees, what we have is opposite to that angle, and that is hypotenuse. So which one has opposite and hypotenuse? That could be sine. So we're going to use sine. Of 25 degrees, opposite over hypotenuse. Opposite over hypotenuse. Right. There's the pencil. I can make the ratio over 1 and cross multiply. So x sine of 25 degrees equal to 195. And we can divide by sine of 25 degrees. It will be best if we just write sine of 25 degrees rather than do the sine of 25 degrees, get a number. So we put all the formulas, the 25 sine of 25 degrees into that, and we don't calculate this number first. Right. So 195 divided by sine of 25 degrees. We've been using this calculator within the degree mode which we set up already, so it should be fine. So it will be 461.4. The length of the string should be feet. So that makes sense. In order to raise a kite 200 feet or 195 feet, the string has to be a lot longer than the height of the kite. So that is the angle of elevation where we're looking up from the horizontal line. Right. We run out of time, so I have to stop here. But I mentioned this many times. We are way behind schedule. So later on I have to do some offline video and just upload, so you will have to watch that a different time than 1 to 3 p.m. on Tuesday and Thursday. So in that case we can catch up with things. But other than that, so the test will be certainly not this weekend, but have to be next week, at least Tuesday, if not Thursday. Right. So when we go close to a test, I will explain what do we need to do and what we need to know. But other than that, do you have any question before I close the stream? Right. Other than that, have a nice day. Have a good weekend. This is the week. It's the weekend if you celebrate. So have a good weekend. See you on Tuesday.